When you think about space, what comes to mind? Probably this huge, empty, sterile void, right? Well, what if I told you that inside the most advanced spacecraft we've ever built, NASA is fighting this constant, invisible battle against some of the oldest inhabitants of our own planet?
And yeah, you're looking at the proof right now. This isn't some kind of weird alien life. Nope, these are actual colonies of bacteria and fungi, and get this, they were grown from swabs taken right off the walls and out of the air on the International Space Station. It really drives home a simple but kind of mind-blowing fact. Space itself might be a vacuum, but our homes in space, not so much. It turns out we can't go anywhere without bringing a little piece of Earth with us, and that includes a whole universe of microscopic life. And think about it, a spacecraft is basically this sealed metal can, right, hurtling through the cosmos. It ends up acting like the ultimate petri dish. It's a perfectly contained, controlled environment where these tiny little life forms can set up a brand new home.
So where do they even come from? Well, they come from us. Human exposure is totally inevitable, because these microbes are just part of our natural, our microbiota. Every single astronaut is pretty much a walking ecosystem, carrying trillions of bacteria and fungi with them as unavoidable stowaways.
Okay, but this isn't just about a little bit of dust or contamination. The thing is, the unique environment of space creates a kind of perfect storm, a double danger, if you will, that can turn a simple, everyday germ into a really significant threat.
So here's how that double threat plays out. On one hand, you've got the stresses of spaceflight. We're talking radiation, microgravity, all that stuff. And it can weaken an astronaut's immune system. But at the same time, some microbes actually become more virulent. That means more capable of causing disease in that very same environment. So you've got the astronaut getting weaker while the germ is actually getting stronger. It's a really bad combo.
And listen, this isn't just some theory. A report from NASA's own Human Research Program puts it in no uncertain terms. They say there's a real possibility that infectious diseases will not only be more common, but they could also be more severe during spaceflight missions. The stakes for the crew's health are they're incredibly high. So let's break that down. When we talk about virulence, we're really just talking about a microbe's power level. It's the measure of its ability to infect a host and cause harm. And what the research is showing is that for some bacteria, spaceflight actually cranks that power way up.
So, if you're NASA, what do? How do you fight an enemy you literally can't see? Well, you start by hunting them down. You have to meticulously track and identify every single one of these invisible stowaways.
Yeah, you can basically think of this as NASA's microbial most wanted list. So the chart over on the left, that's bacteria, and you can see this huge spike for Staphylococcus. That's a super common bug that just lives on our skin. Then on the right, for fungi, you've got common molds like Penicillium and Aspergillus. They're frequent flyers. Now, down here on Earth, they're mostly harmless, but in a sealed environment like the ISS, they can just grow completely unchecked. And this is what unchecked looks like. I mean, those charts aren't just abstract data points. This is actual fungal contamination that was spotted on an interior panel of the station. There was even one case where mold started growing just because astronauts had hung some wet towels against a fabric wall to dry. That's all it took.
And the threat isn't just to the crew's health. It's also to the hardware that's supposed to be keeping them alive. This slimy mass right here, that's a biofilm, a whole colony of microbes that was pulled out of a part of the space station's water system. And this kind of stuff can clog up filters, it can corrode equipment. It's a huge problem.
So what exactly is a biofilm? Well, it's basically a microbial city. It's a whole structured community that sticks to surfaces and then protects itself with this slimy layer. And that protective layer makes it incredibly difficult to remove, especially when you're talking about the tiny little tubes and valves inside a life support system.
Okay, so knowing the enemy and the threat they're up against, NASA has developed a really comprehensive microbial defense system. It's a multi-layered strategy, all designed to keep the station and, of course, its crew safe. The first line of defense is the air they breathe. This dense culture you're seeing shows what was captured back when the ISS had to temporarily use a less effective filter system. I mean, just look at it. You can see just how much stuff was floating around in there. So what's the solution? HEPA filters. These high-efficiency particulate air filters are absolutely crucial. See, in microgravity, the little droplets from a cough or a sneeze, they don't just fall to the ground. They just hang there in the air. So these filters are working 24/7 to constantly scrub the atmosphere clean. And for the water, the process is even more intense. First, they capture humidity right out of the air. Then they heat that water to over 260 degrees Fahrenheit in something called a catalytic oxidizer. After that, it gets disinfected with iodine. And finally, it's passed through an incredibly fine 0.2 micron filter to catch anything that's left. Every single drop of recycled water has to go through this whole gauntlet. But the defense system actually starts way before launch. The astronauts themselves are screened, they're vaccinated, and then they're placed in a 2-week quarantine period. This is all to make sure they're not carrying any unwanted bugs with them. And it's not just the crew. Everything that gets sent to space, from food to equipment, is tested to make sure it meets these super strict microbial limits.
Now, all these systems work great for low Earth orbit. But as we start to prepare for missions that go much further, to Mars and beyond, the challenges start to evolve. We're looking at a whole new microbial frontier.
Think about it. On the ISS, if they have a weird sample, they can just send it back down to Earth for analysis. But from Mars, that's just not an option. It's impossible. So future crews are going to need rapid, autonomous systems that let them act as their own microbial detectives, right there on the ship.
And all of this leads to an even bigger, more profound idea: planetary protection. It's a major international effort, and it basically has 2 huge rules. Rule number 1, don't contaminate other worlds with life from Earth. And rule number 2, make absolutely sure we don't bring anything potentially dangerous back to Earth. So when you get right down to it, our ability to control our own tiny, microscopic world is literally our ticket to exploring new ones. This ongoing, invisible battle against bacteria and fungi, it's absolutely fundamental to the future of human spaceflight.
Which leaves us with a pretty fascinating question to ponder. We are explorers, right? We're driven to reach for the stars. But as we get ready to take that next giant leap for humankind, how do we make sure we don't accidentally bring our smallest and oldest earthly stowaways along for the ride?